Hello, Keith Rucker at VintageMachinery.org. So we've already shot a little video with Paul Hamler here, looking at some of the work he's doing miniature, mostly miniature stuff, but some full-size stuff as well. Some really cool things that he's doing in his shop. But we want to take some time and actually give you guys a shop tour of his shop. And he has both machine shop stuff. He also has a little bit of woodworking stuff, more metalworking over here. But we're going to give you a little tour and kind of show you the tools he's using, and he's got some pretty unique tools that we'll get into. Ready?
Sounds good.
Let's do it.
Do a tour. On the shop tour, this is where most of my projects start, right here. On the computer, do a lot of CAD work in designing and drawing the product. This is a little miniature 1911 we made, and it was completely drawn in a solid modeling CAD program, and then I had the parts 3D printed for making this miniature. Not all of the work I do is CAD. I still do a lot of the old-fashioned by hand, pantograph, mechanical machines. Spend a lot of time here. This is kind of my working area for assembly, finishing work, etc. Right now, I'm in a process of doing a production run on the little 1911 handguns. This is where I'll do all the sanding on the castings, and these are some little sanding blocks that are designed. They're spring-loaded so that you can put your sandpaper in there and hold them real tight and loosen it and rotate it. So do a lot of sanding, finishing, and polishing work in this area. On the Wilton Vice project that I just finished, because there was so much hole drilling in the castings and also for the fixed jaws, or the removable jaws, I basically had these precision high-speed drill presses set up for 3 different operations. You know, in the old days they had them gang, you know, but this is my answer to production work for the small drilling. This was one of the first tools that I acquired when I got into metalworking, a little 10-inch 10K South Bend. I bought it new from South Bend, and I've got all the toys that go with it. But I would say between the South Bend lathe and the closing mill are probably the most heavily used machines in the shop. This guy it's been a workhorse, and I spend a lot of time standing on this mat here. But I love the South Bend, and it gets a lot of work done. I'll actually do some small screw making, like on the custom screws that went into the jaws on the Wilton Vices. They were made all from scratch stock on this machine here using collets, whereas I could have done them on the little Levin watchmaker's lathe. I set this guy up. Right now it's got a small Alorish type tooling block. I think they're from little machine shop or whatever, with the interchangeable cutters. I don't use the Lorish style that often. My tooling of choice is a 4-position turret, and what I could, with this mounted on the compound, I can tool it up with the necessary tools and put the carriage stop, which is indexable to 4 positions. It's not on the machine now, so I can synchronize the two for doing mass production on screws and different components for, the projects. But next to my palm control, that's my favorite machine in the shop. This is my closing. I forget the model number, 8560, 8550. It's was my first mill before I got to Bridgeport. And this has been a workhorse in the shop for many years. I do very little metalworking on this. Mostly what I'm doing is machining plastics, synthetic materials, and wood. Right now, in the spindle is what's referred to as a safety planer. These are used in the pattern industry. They use them on overhead routers. I just use it on the mill. But if you've got some bandsaw stock you want to screw up, I'll typically just double-side, two-side tape the work to the top of the vise. And this safety planer absolutely doesn't use the job of plating small parts to whatever thickness. Here's a project I did several years ago. It was on the cover of one of the Tool Collector magazines. This was a one-of-a-kind, and I made 50 of these at miniature. And I never will forget, if you notice on the front, the fence mechanism that moves back and forth to set your length of cut away from the edge of the board, is inlaid with an ivory dovetail. And by doing the male and the female with a custom miniature dovetail cutter that was made out of a socket head cap screw with a piece of saw blade brazed into it, I made a miniature dovetail cutter for going in and cutting the male and the female cuts on this project. I cannot tell you the hours I stood here twisting this arm, making those passes. I had bursitis for about a year after. But it is the workhorse. We occasionally set it up and put mortise and chisels in here for cutting out the throats where the wedge of the blade goes through. It's one of my favorite machines. Okay, this is a Gorton 375. They refer to it as a universal cutter grinder. And of course you can put different types of stones on the spindle here. Currently it's got a diamond cone shape. This is primarily used for sharpening single lip cutters for the pantograph machine. We'll get Keith to zoom in on a close-up of this little cutter. This has probably been ground and tipped off at 9 thousandths. It's one of the larger tip widths I use. It's machining the small stuff. But basically with this machine, it's got a spindle with built-in stops. You can articulate this guy in all different geometries to position it. An experienced user of this machine could take, for instance, a broken tap, and I've got examples of where it was obviously a broken tap because you can see the information on it, and he ground the boring bar. So with the articulation and the function that you can manipulate the collet that's holding your cutter, you can be very creative and just about sharpen any style cutter you want on this machine. It will sharpen fluted end mills, boring bars, and it's just up to the user's imagination on what type of cutter he wants. I use it primarily for doing single lip cutters for the pantograph machines. I also use it for modifying drills to make a step drill, where if I want to drill a hole and have a countersunk hole, I do it all in one operation. This is a floor model. They make bench models of this, but the machine doesn't get a lot of use, but there's nothing in the shop that can do it when you need it. Okay, this is my one of my favorite tools too. It's a three-dimensional Alexander pantograph. And what I mean by three-dimensional, this table over here is where you put your piece that you're going to copy or scale down. You can also put the spindle over here and use the machine to enlarge devices. So it's bipolar, I guess. I've used this machine recently on making the Colt logo for the 1911s, and also did the models for the Wilton vise. What I did on the Wilton vise is I set a 5C spin fixture up over here and put the parts one at a time into the spin fixture here, put another 5C spin fixture over here, got them lined up, and put the material. Here's a block, a material that was going to be used for another body for the vise. This goes in the spin fixture, and so I can take as many passes as I want. In the case of the vise, I was able to rotate the vise 90 degrees, just 4 rotations to pick up all the geometry for copying the vise and replicating it in miniature on the work table. Same thing on the vise grip. I've got a fixture here that I built, and it holds the parts. In this case, it's got a lock part when I was reproducing and scaling down the flintlock parts. The vice grip parts, each piece was mounted on with a bar at each, just silver soldered on, that could be inserted into here. And in the case of the vise, the geometry was such that really all I needed to do is do the top and the back. So I accomplished that by rotating this fixture over and synchronizing it with the work fixture. The machine is capable of very, very precision work. This is a I'm sorry, it's not a Decal, it's a Alexander, which is a copy of a Decal GK21 3D pantograph. This one was made in England. It's an exact copy of the Decal. But you get your third dimension here on your copy table as it raises and lowers. You sit on your bars up here, you set your scale ratio. This will not do 1-to-1. And I was told the reason they didn't include a 1-to-1 ratio because it was so accurate and so precision, it would be fairly easy for a guy to make some printing plates for currency and copy it on here. So you can't do 1-to-1. And I can't remember the, okay, you can go 1-to-1 reduction, you can go down 10-to-1. Of course, you can do multiples and get it down to any scale you want. But what I did, and we'll get Keith to zoom in and look at a detail of it. This is a Colt belt buckle, and I just mounted it on, fixtured on here. And this is what I'm tracing over to scale down the Colt logo. And you can see when he zooms in the detail that I achieved. Now, taking that one step further, I took a full-size Colt logo, a medallion that went into a Colt handle. I misplaced it, but basically it's about the size of a dime. So I had the Colt logo over here, and I copied around it, and I machined it down to 200 thousandths is the OD. And it's, with the naked eye, you can see the ramped coat and the three-dimensional aspect of the logo. So after I had used a pantograph to scale the medallion down to the 200 thousandths, I took the 200 thousandths master and made a rubber mold and made waxes so I could cast multiple logos from a production run of the Colt 1911s. But again, this is a pretty universal machine. There's a block that could be inserted and locked in. You move it up here, and that locks and prevents the 3D action. So now you've got a 2D pantograph for doing, you know, any type of 2D work. So it's a pretty universal machine. When I made the Kentucky long rifle, the miniature Kentucky long rifle, I had a special fixture plate that held the long rifle, but it exceeded the capacity of the machine. So I had some stops built in so I could copy half of the rifle stock and then relocate it with stocks and do the other half. And that's how I scaled the rifle stock down from 60 inches to 20 inches by scaling at 1/3 scale. Okay, this is a typical setup of using the pantograph to scale this Colt logo down to a miniature size. What we've got is the alignment. We've touched it off so that the copy and the work pieces are synchronized and aligned. And depending on what scale you're scaling down, you always have to maintain a ratio of the radius of your stylus to your cutter radius. So it's, in this case, we're doing 3-to-1, so the stylus is going to be 3 times larger than the cutter. So you have to maintain that synchronization between the stylus and the cutter to get true reproduction. So what you do is with your stylus over here, that I've got a real fine stylus in here, you'll typically migrate down, say, from an 1/4 inch, 1/8 of an inch, and then down to a smaller cutter. You take it in steps. But for every step that you're going, you have to completely trace over every piece of the geometry. And if you miss or go over too far, it's real obvious. You know, it doesn't hurt anything if you can go back and just keep tracing until you get everything covered up. But basically, it's a long, slow process to reproduce this thing and scale it. Probably, if you take it in 2 steps, you're looking at 1.5 to 2 hours. The modern way, and the reason so many of these machines are becoming obsolete, if you could draw this in a CAD program and send it to your CNC mill, it's a lot more efficient than standing here for a couple hours just basically tracing back and forth. But for years, in several different model shops in different industries, this machine here and this process of tracing and reducing it down to your model was a pretty common operation. Stepping back in time a few years, this is a very early pantograph that was made in 1899. I got an old reproduction jewelry catalog that shows a picture of the machine. In 1899, this machine sold for $85. I'm sorry, $75. To put it in perspective, in the same catalog, you could buy a full-size metal screw cutting Barnes treadle lathe for $40. So this was quite an expensive piece of equipment back in 1899. It has a table that rotates for fixturing your work. And I used this machine at a project a few years back, was making some full-size planes that had to have scrimshaw on them. So I had all the artwork after I drew it, I had it photo etched onto titanium plate. And I color coded it so I could keep up with where I was going. And this was my copy. And as I traced around on the copy table, and I had the scale set on the two arms, I had a spring-loaded diamond cutter in the spindle. It was a non-rotating, just a drag type cutter. So it actually, as I followed the pantograph, the artwork, had the scale set, it was scratching the ivory, which later was coated with ink to bring out the artwork. Very precision machine. I was pointing out to Keith earlier, I have an attachment for this machine. It's not installed on it now, but there's an attachment that connects the arms, the moving arms, to the rotating table. And the way it works is if you got a watch or something you want to engrave around a circumference, you line your font, your type up here on the copy table in a straight line. As you move from one letter to the next, the attachment articulates and rotates the table to do a circular engraving around the circumference. I don't know of a modern machine that will do that, to my knowledge. This machine is waiting to be restored. Most people are familiar with this South Bend Heavy 10, but I've got a few features I want to point out that I did on this one. When I was doing the rifle barrels, I had to machine a taper for the barrels in order to swamp or taper the barrels. And what I've got here is a Harding's XY compound. It will fit on an HLV or several different Harding's machines. But what I did is I put stepper motors on it, and through the control program, if I want to do CNC work on this South Bend, I remove the tailstock and I run the carriage all the way down to the end. I pick this CNC compound up and transfer it down here, and now I've got a CNC lathe. I have the Z-axis movement here and the X-axis movement here. You're limited to the travel of the X-axis mainly, but you can get by that by putting program stops and shifting your work, and then just shifting the re-zeroing the X-axis. So it comes in handy to have a mass precision machine that you can do CNC work on. It's a poor man's CNC lathe. The other thing I want to point out here, I was showing Keith, we've got a chuck here, that's a 4-jaw chuck, which is heavy. It's made by the Skinner Chuck Company in New Britain, Connecticut. What's unique about this chuck, it's 4-jaw independent adjusting jaws, as well as a scroll action. So what you set on, say, a rectangle piece or whatever, for repetitive work, you use the scroll function, and it's a pretty impressive, accurate piece of machinery. That was one of my latest finds at the model show. This is my little watchmaker Levin 10mm. I guess you'd call it a jeweler's lathe. I think it came out of the Waltham Watch Factory up in Massachusetts. the strong point of this little 11 is that they had one of the industry's best speed controls. It's possible to do threading on this lathe with a fixed die, and the reversing action on the motor is so fast that you can actually hit the reverse switch once you get up to the shoulder of your threading, and it will automatically reverse. It seems like it does it instantaneously, but I'm sure there's a little delay. But you don't need a self-releasing die head like a, what is it, diacro? Is that what the word? Geometric. So you know, this is not required on this lathe here because of the speed of reversing. I've got quite a bit of tooling with this guy. I got a turret operation, quick compound, as well as the normal compound. But primarily, I use this lathe mostly for freehand turning, with brass and 12L14 type stock. But with the microscope, you can get some pretty detailed geometry with freehand turning versus having to make a fixed profile cutter. But it's a pretty sweet little machine. I wouldn't take anything for it. This area of the shop here is what I try to do is put a wall and separate where I do my sanding operation, grinding operations, and woodworking. And I don't know if you notice it, but in my shop, most every machine that I've got a duplicate. 2 sanders, 2 bandsaws, 2 mills, 2 lathes, so forth. I believe in redundancy. I think there's 1 or 2 machines I don't have. But what I'm doing woodworking back here, if dust is a problem, the machines are on wheels, so I can roll it out the back door and get outside if I'm doing a large production run. This is where I also keep my casting equipment. The 2 major machines that you use in investment casting are the burnout oven, the orange unit here, high temperature burnout oven. And down at the end, the blue box is a vacuum unit. This is a vacuum unit for doing the investment casting. Typically the way the sequence works, in the investment casting, right at the end, it gets real busy. The first thing you have to do is reach inside of the oven and grab the flask that has been burnt out and is ready to cast. Drop it into the vacuum unit. There's a vacuum chamber underneath there. And once it's in the vacuum unit, at the same time, I normally do this in front of the machine, but for demonstration purposes, you reach over here and you get your molten metal that's usually around 2300, well, it's usually around 18 to 1950 degrees, depending on what metal you cast it. You've got liquid metal in here. You bring it over here. You've just dropped your investment flask into the vacuum unit, and you turn the vacuum on. And there's a vacuum meter that tells you that it's sealed and it's drawing vacuum. Once you verify that, you're ready to dunk that metal into your flask. And you pour it in there. When it's filled, you stop your pour, put this guy back, then you have time to turn the vacuum off. Once the vacuum is turned off, you reach over and you grab your hot flask and take it out of there. The reason you don't want to set it in there, this is a silicon pad that it's setting on, so it prolongs the life of the silicon pad. So you just set this guy aside over on top of a brick or something and let it cool. And typically, depending on the size of the flask and the mass of the casting, you'll let it cool anywhere from 2 to 3 minutes until the button loses its red glow. At that point, you pick it up and dunk it into, I use a 5-gallon bucket of water. And when you drop that hot flask, by that time it's probably somewhere around 800, 900 degrees, it cools down. So when you drop this into the water, it actually sounds like an Alka-Seltzer fizzing and bubbling. And then that water will break down the investment, and you can reach in there and grab the casting, or sometimes it falls out before you get a chance to do it, and you pull your casting out, and you're done. You spend the rest of the day cleaning up the shop. In a nutshell, that's this is the main unit for actually doing the metal pouring in the investment casting. There's another process when you speak of investment casting and lost wax casting. They refer to it as centrifugal. There are machines that you put your flask into a centrifugal machine, you wind it up and cock it, and when your metal is melted, you hit a release button and it spins around very fast, and it slings that metal up into the flask. That's referred to as centrifugal. Because of some of the pieces that I cast, which are kind of outside the realm of jewelry casting because of the size of them, I never did feel comfortable with this size flask, or I actually use bigger flasks, spinning around with molten metal. So that to me, this is a safer method. If you do a little small flask where you cast it a single ring or something, most guys prefer the centrifugal, but I'm a vacuum guy. We're going to show you the lathe here, but first let me point out this little yellow benchtop mill. This is what I refer to as the Bridgeport of the CNC trading mills. This little thing weighs about 200 pounds plus. Very sturdily built. They were made back in the 80s for CNC trading machines in the schools. And what I do, I've acquired, rebuilt probably a dozen of these over the years. But what I do is take them and gut the electronics and put modern day amplifiers and electronics and control programs on them to get them up to, a more modern machine. Typically, they came with stepper motors. I typically convert them over to servos, and the control program I run them with is flash cut. It's just a really nice precision machine and well made. The company also made this lathe. It's a Dyna 3000. It was a CNC trading machine that you use in the schools, and this one has a six position 2-turn on it. It's currently got a 3-jaw chuck on it. I'm going to upgrade it to a collet chuck soon. But there's only a couple of projects that I've done because I'm so geared and oriented to doing production work. There's just a few projects I've done over the years where I needed a CNC lathe for doing production work. It's fantastic when you got it. This was a test run testing the G-code. This is a head for a machinist marking gauge. It's a copy of one that was made by an old machinist. And I have used this machine. I have converted it by adapting, putting a pulley on the back side of the spindle and driving it with a servo motor so I could use the spindle as a positioning similar to a 4-axis, but by synchronizing the rotation of the spindle along with the travel of the carriage down the Z-axis, I would mount a rifling cutter and draw the rifling cutter through the barrel as the spindle was being rotated. Very simple G-code, only a couple lines of G-code to accomplish that. So it has been used actually more as a rifling machine than a CNC lathe. This is one of my little CNC mills. We looked at the yellow Dyna over there earlier. This is a machine that was manufactured by a friend of mine, started a company over in Hong Kong. And it's a pretty robust machine. It's not quite as heavy duty as a Dyna. However, it's got a lot of additional features that's not incorporated into the Dyna mill. For instance, it's got a 3-phase high-speed spindle that will run up to like 30,000 RPM. And right now, the machine is set up in a 4-axis environment. Here's a piece that was machined. The logo, or not the logo, but the profile of the Roman soldier, whoever he is. This wax was set up in the 4-jaw chuck, and it was aligned so it was parallel. And the top unit was machined with a single lip cutter that was about a 6/1000 diameter width. And basically, the tool path for machining this is just a raster pattern. Back Z-axis or Y-axis back and forth. The Z-axis comes up and down as it's going across the profile. Once the top of it was machined, it was programmed to rotate the rotary table 180 degrees and then machine out the back. So this profile is it's not solid on the back. It's been machined away in the back to make the unit a lot thinner. And what you do is, if you're going to cast this for an earring in gold or something, you want to eliminate some of your mass. In order to convert this machine to from a 4-axis to a 5-axis machine, you remove the chuck out of here and you install this unit here. In a 5-axis environment, this is referred to as a 3-2 configuration, 3 axes and then 2 axes on the table. There's a chuck that goes right here for your 5th axis. So not only when the 5-axis unit is mounted, not only have you got rotation here on the B axis, but you've also got this rotation here as well. So between this extra axis and this, that puts you at 5 axis. To be honest with you, I've only had a need to use this machine one time in a 5-axis environment, but it does a stellar job. Here's a couple of parts that were cut out. Well, what these were was, this was some parts for a miniature treadle saw, and basically in a 3-axis environment, cutting out the brass and engraving profiles, I tend more to a 3-axis environment. Here's a logo that was machined in the negative, and then the negative low temperature melting metal was put in there and pressed down into here to make that vice grip logo. That was one attempt at it before I went to the final configuration. But the detail of these little guys are pretty phenomenal.
So, wow, that's a lot of stuff you got going on in here. Pretty neat little setup, and doing some really fine, tiny machine work. I don't see how you do that little stuff.
Oh, it's easy.
Well, thank you for your time, and thank you for giving us a tour. I think people enjoy seeing this, and we're going to try to get up at some point in time and do some investment casting videos with them. So I don't know when that'll happen, but at some point in time I'd love to get up and do that. Great.
Well, look, you know, I told you earlier, if I could only have one tool in the shop, it would be the engraving tool.
Right.
I literally enjoy doing that. That's my relaxation. Well, last night after you left, I came out here and engraved a quick piece. And I want to give it to you for your appreciation, or my appreciation.
Oh, my word.
Do you recognize that?
I do recognize that. I'm going to have to get a close-up. It's a little brass belt buckle, and has our Vintage Machinery logo on there. That is unbelievable. I'll get a close-up of that for you guys to see. Thank you, Paul.
You're welcome.
Thank you so much. And I've thoroughly enjoyed my time up here visiting with you. This has been awesome.
Well, glad you enjoy it. I hope the viewers enjoy it, and I have learned something. And we'll keep you posted when I get around. When I learn how to do these videos, we'll get something coming out there.
Absolutely. And I think we're going to probably shoot another little quick video with you. He's got a man cave over here full of just all kinds of really cool stuff, and I think that's worth taking some time. So we're going to shoot that in another video.
And by the way, for you guys out there that are cramped for shop space, I like to point out something, or actually I don't point it out as often as my wife does when we have visitors. She points out the fact that my workshop and my man cave is larger than our house. and that used to be the case until we added on to it recently for a mother-in-law suite. But it was a nice feeling for a while to have a shop that was larger than your house. And I think that's the way it ought to be.
I agree with you wholeheartedly.
There you go.
Thanks, Paul.
Okay, doke.